Hello everyone, good morning and welcome to the class. As it is a day one, just have given a couple of minutes to settle everyone into the class. So yesterday we were talking about like a high level view about this CICD pipeline, right? And we also discussed like we will zoom into every tool here. We will learn the tool from basic till advanced and then come back and integrate. It's not just learning the tool. We have to integrate them in our CI/CD pipeline and see how it works. So today we are getting started with the first tool in the pipeline, which is a version control system. So what is a version control system? Why do we need a version control system? All of that we'll discuss. So version control systems or source code management system. Another name is SCM, right? So source code management system or version control systems. Let's see how they work and what is the version control system. Anyone, any idea what a version control system is?
It is a distributed version control system, and doing the only for coding. One developer is writing the code and take the URL and doing the work only for distributed. I think.
Okay. Uh, okay, let me talk about the need of a version control system. Version control system is nothing but which will help you take backup of your project files, project work, right? So that's what a version control system will help you with. Or else it can help you maintain versions of your files, right? Or else maintain security of your files, whatever your project files are, right? So that's what version control system does. And it just in brief, we'll talk about this in detail. To understand this, let us take a simple use case. Suppose there is some project work, okay? Some project is there and they have placed all the files in this something like a shared drive. Please keep everyone muted unless you have a question. It avoids any background noise. If you have a question, unmute and speak. Otherwise, please keep muted. So this is some shared folder. So they were placing all the project files here. File 1, file 2, file 3. So many files are there. Right? Let's say I'm just giving a scenario where they are not using version control system. There's a person A, person B working in the project. Two people are there. So they have to work on the same file but different changes. A got this file 1 to his local computer, making the changes. B also got the file to his local computer and making the changes to file 1. So both of them were working on the same file and let's say on day 2, okay, B kept the file back, okay, to the shared drive so that everyone else can see the changes and utilize those changes. So he kept this file back on day 2. Okay, so on day 3, A kept the file back, right? So after day 3, this file 1 in this shared folder will have which person changes? Is the scenario clear for everyone? So there is some shared folder, let's say some couple of files are there, person A, person B are downloading the same file and making some changes. After day 2, B kept the file back, means he made the changes and moved those changes to the shared drive so that everyone can use those changes. After day 3, A kept his changes back. So after day 3, like after A keeping his changes, file 1 on this shared drive will have which person changes?
The last updated one.
The last updated one, obviously, right? Simple logic. Obviously, the last updated changes will go in here, right? What is happening here? Person A is overwriting person B changes, right? They don't know that. Even person A doesn't know that he is overwriting it. Similarly, person B doesn't know that his changes are being overwritten. So this is a scenario where they were not using any version control system. So how can we help? How can we overcome these situations? That's where like version control system comes in. It allows people to work simultaneously on the same file without being overwritten or without being ignored. right? We can't do this manually. We need a system which can take care of this. That's where version control system comes in. Is that making sense? So that's one of the reasons. Then another use case is, okay, let's say there is again file one. Okay, file one version one is there. Client came and said they need some modifications. So I modified this file one and made version two. Okay, fine. Now, sorry, file one version one is there, right? So client after a few months, they just want to go back to version one because version two is not working for them. They just want to go back. But I have overwritten and made version 2. I did not maintain backups. So I have to do rework and create a version 1. Am I correct? So it's a rework. How can we avoid this? So always maintain versions, maintain backups so that you don't have to rework. Sometimes if client want to go back to the previous versions, you can switch over to that. Right. So that's what version control system does. It allows people work simultaneously on the same files at the same time. It allows to have maintain backups, versions, right? That is another use case. And what else? Um, okay, let's say application is working fine till 7:10. Something went wrong and application crashed at 7:15. We want to identify this and revert the changes back immediately. Means I want to see what went wrong during this 5 minutes. Means I need a detailed logs which tells that okay, person made changes to file one at 7:12 which led to this crash, and also on line number 8. This kind of detailed logging is needed. Is it manually possible without any system? That's where again version control system comes in, which helps with the detailed logging so that you know what changes, which person is making what changes to what files at what time on what line. Right? These are all the some of the advantages of version control systems. Of course, your code is secure, version control system or source code management systems, right? So who will use it? Obviously, it's mandatory for developers, right? Version control system can manage any static files. It could be Java, Python, Perl, PHP, simple text files, images, anything can be version controlled. So any static files can be version controlled. This is not specific to any programming language. Small normal text files can be version controlled. Docker files will version control with respect to DevOps. Terraform config files will be version controlled. .tf files, Kubernetes manifest files will be version controlled. All of these will be version controlled, right? So it's mandatory for developers, but nowadays everyone will use it because testers, even they write automation test cases. So developers will use it, testers will use it, DevOps engineers will use it to manage, to configure, to version control their configuration files like Docker files, Terraform config files, Ansible playbooks, and so on. So it's not just confined or restricted to developers. Everyone will be using it. So I would suggest anyone who are entering into IT should learn this version control system, right? This is one aspect of version control system to manage your project files, to manage your configuration files, right? Another aspect is to trigger the CICD. Whenever developer make a code change, that should trigger CICD. Why developers code change should trigger CICD, how CICDs are triggered, we'll learn. Okay, fine, developer made a change into version control system, it triggers CICD. What is the part of DevOps engineer here? They are responsible to automate that trigger, right? They are responsible to start the pipelines whenever developers releases some new features. Is that making sense? So there are multiple aspects of learning version control system. One aspect is to manage your projects, to version control your projects. That's the first aspect. Second aspect is to integrate that in the CI/CD. We will learn both the aspects. First, we will learn about version controlling our project. Then we'll talk about integrating into the pipeline. Hope that is clear for all of you what a version control system is, right? So now if this much is clear, I'll step ahead. Can I get a quick confirmation from you guys? Is this clear for all of you? Please be attentive. Any questions, unmute and speak
Yes,
up or
ma'am.
your hands.
Yes.
Yes, ma'am.
Any difficulty, feel free to let me know at that point itself. Okay, so this is what version control system does. Now, so now you understood why I should you learn it as I'm a DevOps engineer, I'm not a developer, right? Hope those questions are clear. Okay, now version control systems based on their architecture, they were categorized. They were categorized as centralized version control systems and distributed version control systems. Means how they were categorized, like I just said, based on their architecture. So we have so many version control systems. So let's see how they were categorized. Your Git is a distributed version control system. Okay, SVN, TFS, these are all centralized version control systems. Git, Mercurial, fossils. These are all distributed version control systems. And distributed version control systems are more widely used in all the modern DevOps projects nowadays, particularly distributed version control systems are used, particularly Git. Almost all the modern DevOps tools modern DevOps projects are using Git. So we will master Git here so that you can work with the Git in your projects confidently. And any sort of interview questions on Git can be cleared by you, right? So let's get started first with the architecture. We'll just have some understanding on the differences in this architecture before we step into the working of Git. Okay. So see here, this is the architecture of centralized version control systems. Just a second, I'm trying to pull in another marker. Give me a second. Okay, so this is the centralized version control system. You are seeing this server, right? This is nothing but central server or the remote repository. You may call it a central server or remote repository. This is the one. All the project work, all the files will be kept here. And you are seeing working copies, right? These are nothing but the workstation of individual collaborators, individual users. If you are talking about development project, you may consider them like developers, or else if you consider it as a DevOps project, DevOps engineers, right? Everyone will connect to this remote repository or central server, bring the changes to their local computer, make the changes and put them back, right? That's how it works. What are the challenges or drawbacks with this kind of architecture? The greatest challenge is always network connection should be there. If for some reasons network is disconnected, you may not be able to connect to the remote server, right? Entire work is halted here. So network connections are needed to work with this. Second one is if for some reasons this remote or central server is crashed, let's say, chances of recovery are less because it works like a single source of truth, right? So chances of recovery are very less. If somehow the central server is gone or lost, that's all, your changes are gone, right? So these are the challenges with this kind of architecture. To overcome this, we have distributed one. And also let me tell you once again, examples which work with this architecture are SVN, TFS, ClearCase. These are all the version control systems which uses this architecture. But we need a better architecture, better systems in modern DevOps projects or pipelines. So that's where comes distributed version control system like this. So you can see again, it will have a central server or remote server. And this is the workstation of each user or each collaborator. Okay, let's say each DevOps engineer. And again, if you see that local repository, okay, we'll call this as a remote repository. And we'll call this as a local repository. So there'll be two repositories. And this local repository is nothing but a exact copy of the remote. Okay, every individual collaborator or user, like let's say DevOps engineer 1, this is the workstation of DevOps engineer 2. they will have a copy of this local repository. And again, how do they make changes? They don't directly make changes on this local repo. Actually, this is the local repo. Okay, they don't make changes directly, rather they'll have another folder or another copy which is called working directory. Means assume some other folder where they make changes. From that folder, they'll move the changes to local repository, which is copy of the remote. Right? And once their changes are ready and complete, they'll push the changes back to the central server. Once they are done, they'll move the changes to central repository. Unless until they move the changes to the central server, no one else can see the changes. Means you can see the changes, or other DevOps engineers can see the changes only when they place the changes to remote repository, because local repository is confined to individuals. Right, that is just confined to each individual. Right, no one else can see the changes, whereas remote repository is shared across multiple people. So here, how does it overcome network issue? Network issues is not, network connection is not needed always. It is needed only to pull, means to share with others, to push to remote, or to get a copy from remote. You see here pull and push, right? Pull means getting a copy from remote. Push means you are pushing some changes to remote. Only these two cases you need network connection, and these two commands are used less frequently, because only once complete changes are done, you will push them to remote. Right? Majority of the time you work in local repository, means no network connection needed. You are just accessing your hard disk. Only once complete work is done, you pull to central server, then only you need network connection. Means if network connection is not there, entire work is not halted. You can still continue working on it. Understood this, everyone? So that's how first drawback is overcome. Network connections are needed only to push or pull. Second thing is, let's say central server or remote server is crashed. Every person is having a copy of it. Do you notice that everyone is having a copy of that remote repository? Right. So because everyone is having a copy of remote repository, everyone is having a local repository, right? So chance of recovery are more. They can just retrieve it from anyone, right? So chances of recovery are more. So that's how it overcomes the challenges of centralized version control system. And yes, it works with this architecture. This is the architecture, general architecture of any distributed version control system. Now we will get into the architecture of Git in particular. Before we go further, any queries? Is this much clear for everyone?
Yes, Preeti ma'am. Correct me if I'm wrong.
Mm-hmm.
Once we copy from the server, from the remote to the local repository. So basically, are we working on the local repository, or we are making a copy of it like a working directory again?
There is some other folder we'll create called working directory, but which is not a copy of local repository. It's just some other folder where we make
Okay.
our changes.
So basically, we are working on working directory only.
Yes. And then move the changes to local repository and then to remote. Correct. Any more queries? Okay. So let us now jump into the architecture of Git. Before that, see, this is the trend comparing Git with other version control systems. This is the Google Trends from 2020. You can also check the latest trend. Okay, you can compare the tools like Git, SVN, TFS, fossils. Git is the clear winner in this category. Do you see the blue graph is for Git, right? So we are learning the market leader here. Right. So now let's get into the architecture of Git in particular. We learned the architecture in general. Now let's go get into the architecture. See, this is your workstation, your computer, right? So you will have a local repository, which is a copy of remote repository. See, this is the local repository. This is a remote where you are copying and creating local repository. So like I told you, you don't directly work on local, rather you work on some other working directory. You make your changes here, and once you make the changes here, you cannot directly push the changes. You cannot directly push the changes to local. No, you have to move them to staging area. See, you have to move from working directory to staging area, from staging area to local repository. But what is the staging area? See, assume that working directory is some folder, or if you are Linux person, let me call it as a directory or a folder, right? From there, you can't directly push to local. There'll be one more area or a layer called staging area. Staging area is nothing but index area, a virtual area. Okay, it's a virtual one. So where you have to move your changes, right? From staging area only you can move to local. From local you have to move to remote. Means it's like a 3 steps before your changes goes to remote. From working directory to staging area, from staging area to local repository, and from local repository to remote repository. Yeah, this is there are 3 steps how your changes progress, right? And this is called Git tree, right? And you might be having a question, what is the importance of staging area? Does it has any importance? Yes, of course. It works like a preview or else a pre-check before your changes goes to remote. Preview or a pre-check meaning, let me give you a small example. In couple of minutes, we are going to jump into the hands-on. We'll see all these things, but let me just give you an understanding here. Let's suppose there are 10 files in the working directory. Okay, you want to just move only 5 files to staging area, right? So, sorry, you want to move only 5 files to local repository. So you move only those 5 files to staging area. Means it's like a giving you a preview or else pre-check before what changes are going to local. Here there are 10, but I just want to put only 5 into my local. I just want to put 5 into this local, right? So only 5 files I'll move into staging area. It just helps me to confirm what changes are going into local. Right? We'll see that practically, but imagine it's a virtual layer, virtual area where your changes should first go in and then to local and then to remote. Right? So that's a Git architecture. We are going to see all of these things in some minutes, a couple of minutes now. Before that, let me tell you another very interesting part.
Uh, Priti, I think make changes. I think we modify the files within the work directory. After work directory, move from use the stages area in a git add to staging area. Any of the move after committed is means stage area to local repository with the respect of, and after that before the pushing of the local message is the remote repository ensure the local branch up to date resolve, right?
I'm not explaining commands now, Satish. I'm just explaining the architecture and then we'll go to the commands.
No, it's only yeah, okay.
So now let me talk about an interesting part here. This working directory, this local repository. We are talking about folders, right? Physically, it's a same folder. It's a only one folder, same folder or directory, whatever you call it. Then how come you are saying working directory and local repository, isn't it? Physically, they are same. Physically, it's one and the same. Physically, same folder. But logically, they are different. How can it logically different? Let me explain you. Let's assume there is a folder or a directory, okay, which I have created. Okay, let's say I'm calling it as a local repository. Now, if you just created a file here or copied from somewhere and placed a file here, okay, you just created a file here means that particular file is said to be in the staging area, sorry, the working directory, right? And then if you run this command on this file, then it is said to be in the move to staging area, or we call it is in the staging area. Then if you run this command, then it is said to be in the actually local repository, right? So same folder, it's the same folder. I'll create some folder on my machine, on my laptop, and I'll do that. So it file is present physically in the same folder, but this is how logically it is different depending on the status. Understood, everyone? If you have just created a file, means it is said to be in the working directory. If you have added, means it is said to be in the staging area. If you have committed, means it is said to be in the local repository. But physically it's in the same folder. That's why that's a same folder or directory. Staging area is nothing, not a physical directory. It's just a virtual layer. Clear, everyone? And there is another interesting part. So, there is another interesting part. How do you create local repository, right? How do we create that local repository? There are multiple use cases or scenarios how we create them. Let me go through one by one. Let's suppose it's a new project. Okay, new team is formed, new project is created, a DevOps project. So you have to provision your infrastructure automatically with a Terraform, right? So what do? You create some Terraform config files. Means there is nothing on remote yet. It's a fresh project. So you create an empty local repository. Okay, create your Terraform config files and then move them to remote, right? So this is the first use case. You do git init. Those are the commands we learn separately. That's how you create an empty local repository, then create Terraform config files, and that's how you work on it. Later on you push to remote. Another use case is it's an old project. Okay, some 3-year-old project, you joined this team already, DevOps team is there, Terraform config files are already there, so there is something on remote, so you copy from remote and create a local repository, isn't it? You join the team now, first you need to create local repository with a copy from remote, right? So copy from remote by using git clone commands. We'll learn commands separately, okay? So that's how, those are the two ways you can create local repository, by doing git init or by doing git clone. First, we'll get started today. Assuming we are a new team, new project, we'll get started this way with this part. Later on, of course, after learning these things, we'll also create using the second part. First, we'll get started with the first one. Got it clear, everyone? If this much is clear, we'll jump into the hands-on and see these components, whatever we were discussing till now. Good to go.
Yes.
Any
Yes,
questions?
ma'am. Yes.
All right. Thank you all for confirming. So now that we understood the Git architecture and all, let us install Git. How do you install Git? We'll see. Before that, Git works on multiple operating systems. It works on Windows, it works on Linux, Mac, and so on. It works on multiple operating systems. So for this, you don't have to get AWS instance and all. You can work on your laptop also. Right? Feel free to use your laptop. It's a lightweight tool. You can comfortably use it. By the way, only installation steps differ from OS to OS. Once installation tool is done, the commands, the concepts of Git remain same. Okay, that is the thing you need to be clear about. Okay, so now let us install Git. How do you install Git? Before that, I want to show you our LMS where you will find all these installation docs, everything. I think by now you all got access to your LMS, right? Whoever have enrolled, I think majority of you have enrolled and every one of you have got the LMS access now. So once you log into your LMS, go to my learnings, because it's not a trial access, you got the actual access. You can go to that October program. For me, it's not added, but yeah, you can go to your October program. October 2025 will be there. So you will see yesterday's demo class as well as today's video will be uploaded here as Git one, right? When you go to that Git one, at the bottom you will see lab exercises. Let me go to the lab exercise. Quiz relevant to that particular day and interview questions of Git. Okay, see here. How can you simplify commit history? We are going to see these commands today. You have a quiz on those things as well as see download Git on Windows, download it on Mac. So how to install it on multiple operating system is there. Okay, this is on Linux. So what commands you need to execute after that, everything is here in the assignment part. So you don't have to worry or struggle writing or memorizing the commands. Stay relaxed and listen here. Once it is done, you can get started with your hands-on. Okay, all right. So here in the, interview questions are also there, or like what is Git, what is repository, beginner level, because we just started the tool today. Okay, and then yeah. So if you just go to Windows, you have all the download command, URLs here, how to download, what to do, everything. Okay, let me show you what you have to do. Just go to Google and download Git. Here all the URLs were there. Okay, but I'm not using, I'm not directly clicking those URLs, rather I'm just going this way. Okay, so go to download Git, you will see gitscm.com, the official website for Git. See under downloads, depending on your operating system, if you are having Mac, go for this. You can run this command, brew install Git, to install Git. Or else if it is Linux, go here, depending again on the distribution of your Linux, run those commands. If your laptop is Windows, go here, depending on your again 64-bit or 32-bit, whatever, you download this installer. I think it's pretty much clear. Download the installer, double click that installer, means run the installer. It will ask you to click next. That's how you should navigate it to that wizard. If you still need step-by-step help, assignments, command steps are there. But if you still need the screenshots and all, for particularly for Windows, because it just goes through this, you can just go to your lab notes. Where is your lab notes? Of course, in LMS also, here is the lab notes. Lab notes is different from lab assignments. If you go to lab notes, here you can use, you can see the Git. Open this. Here you will see the presentation also. Presentation where I'm showing this architectural diagram and all. This presentation is also available here. Okay. Also installation on Windows PDF available here. See, including the screenshots, like you have to click next, that's all. See, this is the installer, double click, keep hitting next, next. So that's how you should navigate through the wizard and your Git will be installed. Everything is there, including the screenshots, right? And of course, our commands, our hands-on exercises will also be present here. You can use this or use lab assignments. It's up to you, whichever you feel convenient. Okay, so there were two formats available for you. All right. So let's come back. Now you know how to install it. Follow this step and install it. Mine is Mac. If it is Mac, you can launch the terminal. Okay, launch the terminal if you are using Mac. Right. So Git is already installed for me by using homebrew command. I installed it. As it is installed, you can run this command. You will see Git version means Git is installed. If it is Windows, you can go to start menu. And then the start menu, you can use git bash. Git bash is the window where you should be writing the commands. Right? Git bash is the window where you have to write the commands if it is Windows. Hope you all can launch it. Send git URL for Windows. Samir, it is there in the website. Sorry, having some cough. Yeah. So it is here. The in the lab assignments, because I can't copy paste here in the Zoom chat. Here is the URL. Go here to this URL. You can see the URL to download it on Windows. Maybe let me check if I can share it. Yeah, okay, it's working. Let me share it. There. Okay, this is the page. You have got the URL to download for Windows, right? So yeah, for me Git is installed. Let's go to my terminal. Okay, fine. Git is installed on my Mac. But now you have to tell Git which folder it has to version control, isn't it? Git is installed, but you have to tell where which folder it has to version control, which folder is having your project files, isn't it? So, yes. Okay, so this is the, I just want to create some project folder on my desktop. Let's assume it's a new project, there's nothing on remote. So now I want to create a local repository and version control it with Git, right? So I just want to create some folder here. Make directory, mkdir, Linux command to create a directory. Please keep muted. Any questions? Unmute, otherwise please keep muted. So I'm creating some folder to place my files. I can use these Linux commands. I'll teach you these Linux commands separately. Just I'm using the basic one. mkdir means it will create a folder or directory. If you are not comfortable, perfectly fine. You just go this way to the folder. This is my desktop. Okay, right click and you can create it. Right click, new folder. Perfectly fine. Right? You don't have to use Linux. We did not learn Linux yet. Perfectly fine. I have created some folder. This is where I would like to put all my project work. Okay. If you it's already created, if you do ls means it will list. You should see that folder here. Git demo. Yes, it is there. Right. So, okay, fine. I have this folder. Now I want to version control this one. So let's go into this folder. Again, like I told you, you may double click, go here, or else from the CLI, go to the folder. Okay, Git demo. Now I am inside Git demo. How do you know? PWD, present working directory, will give you the path where you are sitting. That's how you would know where are you. Okay, that's how you check in the from the CLI. You can use the same commands in Git bash also, in your Linux also, in your Mac as well. If you are not comfortable, you can use just simply the GUI also, perfectly fine. All right. Okay, this is the folder. Now, I would like to place all my project files here and I want to tell Git to version control any files in this folder. I have to run the command git init. Git init means initialize Git.
Local repository.
Please keep muted. You are unmuting and speaking. For everyone, I'm telling, please keep muted. Your background discussions are audible. Please keep muted. Good. Git init. Okay, git init will initialize Git, start Git, or it's a way to tell Git, hey Git, please version control any files in this folder because this is my project folder. I will keep my files later on. So run the git init. See, whenever you run this, it tells you initialize empty Git repository. Means now this Git demo folder has become your local repository. This is Git demo folder sitting on my laptop. This is nothing but the local repository. Like we learned, that's nothing but the working directory. Let's see. Let's see how it is both. Okay, fine. Git init is done. If you see the hidden files, how do you see hidden files? ls minus a dot git is there. Right? See here also, if you don't want to use Linux commands, always just use normally. See dot git is there. Means whichever folder will have dot git means that is nothing but a local repository. I have created local repository successfully. Right? So, okay, fine, local repository is created, but where are the files to version control? Okay, let's create some file. You may just go here again, right click and create a file, or else let me use some Linux command touch. Touch will create a file, touch file1.txt. Right? I'm just creating text files. By the way, you can create any file. Some time back we just learned, right? You can create any text, any static files can be version controlled by Git. It need not be a Java file or .NET file or PHP file. So it's up to you. Okay, if you are interested to create some programs, if you know some programming, you may create any program files, or else if you are tester, test files or any text files are also fine. We are learning it with some dummy text files. The same concepts are applicable for any file. It could be Java file, .NET file, or a Terraform config files, Ansible playbooks. We are going to create our projects. Once Git is completed, we are going to create projects using these tools like Terraform projects and all. So we'll version control those files. It could be any file. I may create some Terraform config file also. Right? Hope I am making sense. So for clarity and for simplicity, I'm just creating this file. Okay, fine. File is created. But where is this file? If you just take a step back and revise what I have explained some time back, I told you that creating a file means where is that file? Anyone can recollect our discussion some time back? Just I placed a file means
It is in working directory.
here you
Working
can.
directories.
Yes, so you can run git status to confirm that. It will tell you untracked file means git knows there is a file, but git is unable to track it. Yes, git know, okay, there is a file, git knows it, but it's not able to track it. It's giving you clue to add. It is asking you to add means where is that file?
Staging area.
Always you should refer to this architectural diagram and understand it. This should be on the back of your mind. So it's asking me to add. So where is it?
Staging area.
It is asking me to add, not a
But currently,
Working
working
directory to
directory.
staging area. I think
It
git
is
add file
asking
name.
me to add so that it can
Git
track.
add file name.
Git add that particular file name. So now if you see the status, can you tell me where is this file now?
Staging area, I think.
Ignore this one. Okay, this is my Mac system file. Just ignore it. So it is
It is
asking
in
me to changes to be committed.
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 Yeah.
Where are those?
Working directory
Staging
to
area.
staging area.
Changes to be committed means they are in the staging area. But do you
staging
see that?
area.
Physically, it's the same folder. It is in the file is in git demo folder only. But sometimes we are calling it as a working directory. Sometimes we are calling it as staging area. Now, if you have to comment, git comment minus m. Minus m means message. Message is mandatory. First file, something like that. Right? This message is helpful when you see the changes later on and understand what this commit is all about. Okay. So now if you do the status, it will tell you, ignore this one. Okay, just a second. Okay, just did a commit again. Huh. Mm,
Oh, so you have to create it for that configuration file username and password.
second dummy file. Okay, done.
Git to config -hyphen global username and password. You have to create after
No,
that.
that is only one time task, Satish. We don't have to do that. Here it is missing with a just a second, not staged. That's what it is missing. Just give me a second.
Okay, okay.
Right? So you will see like working directory is clean, working tree is clean. Clean means whatever changes you have, everything has gone to the local repository. Means I have one file, it's in the local repository, right? So it's saying working tree is clean. If you want to ensure what are all the files in the working directory, I mean whatever in the local repository, git ls files. See, ignore this .ds store. Okay, that's a default file generated in my Mac system. So you just follow this one. Say that file is there here. Is that making sense, everyone? Let me repeat it with another file so that you should be clear with. Touch, I'm creating another file. Now, can you tell me where is this file?
Working directory.
Git status will tell you untracked file. Untracked means it's a new file. Git knows there is a file, but Git cannot track it. It will ask you to add. Right. So what I'll do, git add file 2. I'll add the file. Now can you tell me where is this file?
Staging area.
Changes to be committed means yes, it is in the staging area. Also, if you see ls, two files. Git ls files, two files because that is moved to staging area also. Understood? So what you have to do, git commit
-m
minus m,
initial of initial
some
messages.
some message. Message is like a comment which will help you what changes are going in there. Like let's say, okay, second file created, right? So your changes were, you can see the status. It should be clean, but because of this file, it's showing this. I should commit this file also. Means I should add this file as well. But ignore it and understand that this is how your changes move from local, I mean, working directory to staging area, from staging area to local repository. Is this much clear, everyone? Understood? Or should I repeat with another file, or is this much clear? Any questions, confusions here?
First, we just confirm one thing.
Mm,
Once we commit the
mm,
file will be goes to the local directory, right?
correct.
Along with the
Local
message.
repository.
What was the message we are defined on that?
Yes, correct. See, one more thing. You don't commit the files. You commit the changes. Means whatever in the staging area will be committed. That's why, see, your commits are not having the file name, right? Git commit minus m some message. That's it. Means whatever in the staging area will be committed. In our case, it's only one file. Maybe if you are working with multiple files could be in the staging area. All of them will be committed. Understood? Also, whenever you run this commit command, a unique commit ID is generated, which is called hash code. You can see here. See, so many commits we have done, right? When you run git log, that's what I'm talking about. Logging. A unique hash code will be generated for every commit. And your commit message, the author, because I am registered with my name on my MacBook, the date and the timestamp when the changes made. Like I told you, right? You cannot identify what this commit is doing. So you put some relevant message here so that you understand what this commit is doing, right? That's how log will help you. If you just want to see brief log, git log one line, that will just show you first 6 characters of the commit is enough, and then the commit message, right? I have given the same message multiple times. One last time I'm just repeating. Okay, so this would be in the working directory. Untracked means git cannot track it. I have to add it. Git add. I can add file 3 and one by one, or else I can put a dot. Git add dot means all the files will be added if you have multiple files. So the files are in the staging area. See, changes to be committed. Because I did a dot, even dot ds file, some default backup files were also committed. Now it's asking me to commit. Git commit minus m, let's say third file. Or else in reality, okay, Terraform file modified for EC2 changes. EC2 is some AWS service. So some EC2 changes were made on the Terraform file. Some relevant, meaningful comments so that you can understand after 10 days or 1 month what this commit is doing. Is that making sense? Of course, I just created a file. I didn't make any changes, but if you're making changes, that will be helpful. So actually Git status should show us as clean. But because of the DS file, it's showing it. That's okay. So ls. Git ls files will show you all the files in the staging area or local repository. Hope I made the things clear for everyone. How it is the same folder. Git demo is the local repository. Git demo is the working directory. Right? It's the same folder, which is a local repository, which is a working directory. Physically, logically, that's how it is different. Any questions from anyone?
Commit -m is only for understanding what changes we are made for that file, right?
Message, M stands for message, right? You
Message.
have to provide some message. Message is like a comment, right? To tell what these changes are all about, right? Why you created this file for some kind of information so that anyone looking into those comments can understand, okay, why this commit was made. Right? So let me take you through the commands we have discussed till now. We just discussed the commands, git init, right? Then, sorry, git init, git status we discussed, git add, file name we discussed. To add all the files, bunch of files, git add dot, then git comment -m, some message, right? These are the commands. And of course, we also discussed git log, git log, one line to see the brief log. Anything else we have seen? Git commit -m, git add. Some Linux commands, very basic Linux commands like ls cd to see hidden files, ls -a, then pwd present working directory, mkdir to create a folder, touch to create a file. These Linux commands, very basic Linux commands. We will separately again revisit them, but optional now. Later on, we will learn it, then you can use it. This is optional for now. If you are comfortable, you can go it, but we'll learn them again separately. And we have discussed about Git architecture, and we have like visually seen, like we have visualized the how that local repository working directory are going to work on here. Any questions, any confusions from anyone? See, one thing I want to tell, Git is a very interesting tool, a tool with which you can play around if you learn it properly. If you don't learn it properly, or if you have lot of confusions, it will be a nightmare to work with Git. It is very simple and very interesting tool as long as you understand it thoroughly. So make sure that you are following here point to point. Any questions, confusions, feel free to raise your hand. So, and also another thing, whenever you are learning it, always relate to this architectural diagram. It's asking you to add, means it is in the working directory. You have to move it to staging. From staging only, you have to go to local repository. Got it clear, everyone? Understood?
Yes.
Okay. So till now, I'm just taking one more step. Till now, we are just creating files, right? After creating files, you may have to write some content, some configuration, some script or whatever. Isn't it? Depending on the file, depending on the context, we have to do. So to modify those files, how do you do that? You can just go to this folder. Yeah, you can just go to this folder, you double click your files. Okay, it will open in the notepad or whatever you have in your system. So you edit the files this way, right? So you double click and open the files and you modify them this way. You add any content, whatever you want here, right? This is how you can do. Means these are nothing but editors, right? Your notepad, notepad plus plus or Word document, Any of the editors you can use. In reality, like professionally, there is some editor which we can use. Let me take you through to that editor. This is just optional and an add-on. There are so many editors like IntelliJ, Visual Code Basic and all. So Visual Studio Code, right? This is an editor. Don't worry, it has nothing to do with coding or it has nothing to do with the Git. Okay, it is just an editor. Like you use Notepad, Notepad++, or Word documents and all. This is the editor. You can download this Visual Studio Code. Again, it works on Windows, Mac, Linux, and so on. So you can download. Once you download, just launch it. That's it. As simple as that. See, here is mine. A better editor, a professional way to edit your files. It could be any files are supported with this, right? So initially you will see something like this. Go to file, open our Git folder. It is on the desktop. So you will see all the files. It is easy to edit this way, right? So that's what you see here. Another interesting and important point. Rather than going to this terminal to run my Git commands, from now onwards, I can just launch my terminal in the same window. See here, you can launch your bash window if it is Windows. Run any Git commands you want. As simple as that. Everything a unified window where you can see your files, your project, where you can run your Git commands. Isn't that good? Just to make your activities more better, this is the editor we have. So many editors are there. If you're already using some editors or if you have interest in any other editor, you can use any editor of your choice, right? Can you just install it and try out this one? It's nothing to do with your Git or programming. It is just an editor like a notepad, a better editor for IT professionals. Yes, Satish, sorry, Samir, any question? Yeah, you click on open, not GUI. You should go to Git bash, the first one, that's all. Not the Git GUI or Git CMD. Go to Git bash and open it. Okay, so that's your editor. Okay, fine. First, let me clean up everything. Git status, it's showing some changes. Let me add. That's a dummy file. Okay, don't consider this. Git commit -m all files, something, some message I'm giving. Git status should show me clean. Perfect. Right? So till now we just created a file. Now let's suppose I'm adding some modification. A dummy line I have added. You see, this is another advantage of VS Code editor. You can see if you keep your cursor, it tells it's modified. Modified means where is that change? See, whether it is a new file, whether it is a modification, Git works in the same aspect. Modified, some change is made. Where is that change initially?
The local system working directory.
Working directory only. You can see Git status. See, it is not telling untracked. Do you see the message difference in the message? If it's a new file, it will tell you untracked. It is telling not staged. Not staged means where is it?
Working.
Working directory.
Unstaged changes or untracked changes, or in where are those unstaged untracked changes? Working directory,
Working directory.
right? Also, so it is telling you changes not staged, please add and commit, but it's not telling you untracked. So what is the difference between untracked and unstaged changes? Anyone?
It is a new file, but it has been modified.
New files will be shown as untracked. Modified files will be shown as unstaged. Both are in
Working directory.
Only.
working directory only. Both are in working directory only. But that is the difference. So whenever you see the message, you should understand whether it is a new file or a modified change. Whatever it is, the flow is same. What you have to do? Add and commit. And if it is a new file, if it's a untracked a new file, you have to add and commit separately. If it is unstaged also, you can do the same along with it. You can do the same, add and commit separately, or else you can also do this. Cursor is not coming. You can do git commit because it's not a new file -am, add and commit with a single message, single command. You can do it because it's not a new file. Only for unstaged you can do this. Am I making sense? Clear now? Is this chart clear? So what I should do? Because it's unstaged, I can add commit separately, or else I would prefer add a flag, m flag, modifications. Got it right, everyone? So that's how. Means the point to note is, see, working directory is clean. Every change is more. So the point to note is either it's creating a new file or whether it is a modification, every change should go through working directory, staging area, and local repository. Got it right, everyone? Any questions or confusions? Hope the things are clear, right? And one more thing, whenever you are running this commit command for the first time on your system, okay, it has to register, right? If you see here, you will see it will be registered with some username and some email ID kind of, right? So to facilitate this, whenever you run the commit command for the first time in your system, it will prompt to run, give username and password. You have to run these commands, git config global. Because it's not first time for me, it doesn't ask me user.name, put your name. Okay, I'm not running it. And then git config email ID so that it can track with those details. User.email and some email ID. So run these commands for the first time so that it will track with those names you provide. Okay, for me, for the first time, I have given my MAC details. So it was registering with those. And by the way, remember one more thing. We are still in our local repository. We did not go to remote yet. Right? Where is this Git architecture? We did not go to remote. We are in this yellow box only. Before you go to push your changes to remote, there are many other things you have to master. Right? So we will learn all of them before we push our changes to remote. Whatever config commands I have shown you just now, and of course, every command I used are there in this lab notes. With explanations, it is there. See here, git config global username, everything is there. Not only that, in your lab assignment also it is there. This is the lab assignment. Here also, yes. Right? You don't have to search or you don't have to struggle more to do the hands-on. Hands-on is cakewalk now. Also, still if you are stuck up with all these details provided, with all these essentials provided, you can ping in the WhatsApp group. A separate private WhatsApp group is created with all the registered candidates. You can ping with your queries there. Is this clear, everyone? This is only for unstaged file only. You can use -am together. This command -am together only for unstaged file. If it is untracked, because it's a new file, you have to add and commit separately only. You cannot add and commit in one go. You can experiment. You can try doing it. Okay, it will throw you error. Just try doing it, experiment those things. Any more questions? I think this much is enough for today as it is a day one. You can set up your gate, you can explore your LMS, you can spell your lab notes, your quiz, your lab assignments, your lab notes, and try to do the hands-on till this part. Also set up this VS Code editor, set everything ready for the next class where we'll deep dive into much more interesting concepts. Any questions, anything else from your side, feel free to bring them up. Last 15 minutes is for you. So any questions, anything you want to flag up?
Okay, ma'am. I just have one question. Sorry for that.
Yeah, please go on.
Uh, the git command -am, what was the purpose we are using for -am?
Add and commit. Instead of running the command separately, you can run add and commit together. That's what is -am. See, that's what this side I wrote. Add and commit. Here also you can do the same for unstaged files. You can also do this. Add and then commit
First
separately.
add and then commit. Okay.
Or else because it's an unstage, you have this option to run both of them in a single command by using a flag, m flag. It is equivalent to the both top above commands.
Got it, ma'am. Thank you.
Or,
So
okay.
unstaged means Preeti already the file is there. So we are doing the modification and we are doing this single command add and commit only for
Like
that
I placed here or, right? You can do it separately or else,
separately also we can do in a single command.
yes. If it is
That's
unstaged.
that only unstaged. If
Huh.
it is untracked means we have to do compulsorily separately add and commit
Yes.
as it is new file because we have not modified
Right. It is not there in the staging area. So you
staging area.
can't use commit -am flag. A flag cannot be used for a new file.
First it should be added, then it should be
Ah,
committed only for the first for new file.
correct. Correct.
Huh? Right,
Yes.
right, right, right. Thank you, Preeti.
Ma'am,
And
can you
by
please
the way,
confirm?
one
Sorry.
second, please. So whoever have completed your registration, you all got LMS access, added to WhatsApp group, right? If not, please ping Mr. Raj. You know Mr. Raj number, right? It's on the website. By now, you should have all access to your LMS. You should be having access to your portal, everything. So just ping Mr. Raj on this number. You should be added to the private WhatsApp group. If not, please ping Mr. Raj and get those things done so that you can get started with your hands on, you can get started availing our WhatsApp support. Okay. So this is
So,
all from my end for today. Yes, I'm taking up the questions. I'm not closing it. Just give me a minute. So please make sure you are completing your hands-on, your quiz, everything before you join the class tomorrow. Hands-on is mandatory. Okay, just listening will not work. Hands-on is mandatory, and I understand like you are all working professionals, busy people. So to save your time, we have provided assignments step by step here. Just you can anyone can do the hands-on blindly also. Even though you miss the class, follow this assignment and do the hands-on. That will help you to follow up the next class easily. That's how you will be job ready in 2 months. Just listening in 2 months will not make you job ready. Make sure you are following whatever instructions we are giving here. Yes, please go on. Some of you are asking a question. Please go on now.
yeah, Preeti, after the class, just I will talk with you personally. This is Ramu, Preeti.
Okay, sure.
Okay,
Uh,
okay, okay. Just remember me, Ramu. Right.
sure, right. Any
Thank you,
more
Preeti.
questions? So if not, that's all for today. Get started immediately if you have time with the hands-on. See you all tomorrow and reach out to us on the WhatsApp if you have any further queries. And okay, there are some chat messages. Let me go through them. Samir, sure, Samir, you can ping me after the class also. Perfectly fine. All right, then that's all for today. and the recording will be uploaded in some time into your LMS. So everything will be in your LMS. You don't have to struggle, search and all. Complete your quiz, complete your hands-on, complete the like listen the recording also if you want to gain confidence, and see you tomorrow. That is all for today. Thank you all. Good day. Bye everyone.
Thank
And
you so
Rahul,
Thank.
stay back so that we can talk.
Okay. Thank you. Thank you, Preet.
much.
Bye everyone.
Bye-bye.